Hello and welcome to Gamer Maven. Today we will take an in-depth look at the graphical settings inside the newly released Suicide Squad, Kill the Justice League game. We will discuss about how much each setting impacts the average frame rate and the stability of the game, that being the 1% low frame rate. Sometimes you may wonder that you play a game and despite the fact that you have 60+ FPS, the experience is not enjoyable because the game stutters and the motion is not fluid. It feels like each frame hangs on something before being displayed. Today we will see how poor implementation of some graphical features and improper CPU scheduling and core utilization can lead to such scenarios. Do not worry if these seem to be very technical terms. I will explain them and provide you a means of assessing the situation and finding a solution. We begin by taking a look at how the game runs at 4K maximum settings with Deep Learning Anti-Aliasing (DLAA), which is our reference point during the testing. Now you can see how each anti-aliasing option performs and looks. TAA looks way softer than DLAA and has similar performance. You can easily spot the differences at the top of the tower. The metal bars start to look jagged as we decrease the anti-aliasing method. In the case of TAA, there is not much of a performance difference between the different levels, but we notice a difference of softness. FXAA is just a little bit better than no anti-aliasing at all. Our testing methodology is to set all the possible graphical settings to the highest value provided by the developer, and this is what we call the reference point. Then we focus on one setting at a time, decrease it to the lowest setting and write down the performance impact each decrement has. At the end we compute the average frame rates and 1% low frame rates to assess the playability and stability of the game. The best looking one is Deep Learning Anti-Aliasing, but it comes with a performance cost. We also take a look at how DLSS Quality handles the anti-aliasing. DLSS introduces a CPU limitation for the RTX 4090. You can see the GPU usage in the overlay. Now let's take a look at how the best three anti-aliasing methods compare to one another. DLAA and DLSS are extremely similar. There is no major difference. DLSS is a little bit softer than DLAA. DLSS introduces CPU limitation because the game is not optimized to run on hybrid CPUs, but it smoothens out the frame time graph, therefore providing better stability through more consistent 1% low frame rate. We advise against using TAA because it destroys the sharpness of the image. Now let's take a look at what the visual differences are when raytracing is enabled in this game. We can see ray-traced reflections on the windows of the building with the big chimney and some minimal ambient occlusion differences for the building in the middle of the screen. The visual differences are not significant and do not justify the performance hit, especially on the 1% lows. With raytracing enabled, the game stutters a lot and the experience is poor and annoying. Raytracing is in our case the feature which introduces 1% low frame rate instability and also frame time latency up to 75%. This is because the game is not well optimized to make use of the performance cores of the i9-14900K. The game distributes the CPU tasks using the Windows task scheduler most probably, therefore some workload is handed to the efficiency cores, which are not meant to be used by demanding application because of having lower clock speeds. Now let's take a look at how each individual graphical setting looks. We will compare the highest setting with each of the lower ones. The level of details seems to impact the draw distance of the shadows and reflections. We can see that the shadows on the building are more prominent when on the highest level of detail. Also, we can see that far away reflections are either lower resolution or inexistent as we decrease the level of detail. The volumetric fog quality impacts the density of the volumetric fog. The draw distance of the volumetric fog is also impacted and the way the fog interacts with light and casts shadows on the buildings. We can see that lowering the quality from high does not provide the same rich shadows on the buildings. The texture quality impacts the resolution of the textures and the VRAM usage. There is very little VRAM difference between high and medium, but when textures are set to low, the VRAM usage drops by 2 GB, leaving a total of 8 GB being used by the system, too much for the quality of these 2008 looking textures. The shadow quality has very dramatic effects when changing from high quality downwards. We can see that the shadow of the tower in front of the building in the center of the screen has much lower coverage and resolution. Also, we notice several differences around the lightning sources on the building and the objects the light coming from them interacts with. On the lowest quality, these shadows are inexistent and the performance gain is 0%. With raytracing enabled, there is no much difference on the average frame rate when we change graphical settings. The differences are at most 5% and some of the results are negligible. Concluding from this graph, we can say that raytracing is responsible for the odd results. We see several changes in the overall image quality, but there is no significant impact to the average frame rate. The only notable differences are the lowered usage of VRAM and increased stability in the frame time graph. There is a bigger difference when we take a look at the 1% low frame rate, and this is mostly because these settings work with the raytracing techniques used in this game, impacting shadows and reflections. The biggest difference here is when we change the level of detail from high to low. This is because the ray-traced reflections are no longer rendered in the distance. The quality of the textures affects the way light is reflected at night and during the rain on different materials. It is important to note these results vary depending on many factors such as time of the day, weather, number of reflective materials. We take into consideration the worst-case scenario we have found. It is very strange that changing the texture quality from high to low has a 62.5% increase in the 1% low frame rate, but the average frame rate is lower or very close to the initial value. The textures in this game do not look great even at the highest setting, and at the lowest setting make the game look from 20 years ago, despite requiring 8 GB of VRAM at 4K. The game in the current state is definitely meant to be played without raytracing because of the stability issues. In this graph we can see that if we disable raytracing, then we get a tremendous increase in the 1% low frame rates. You can check your 1% low frame rates by using MSI Afterburner and displaying the frame graph in the on-screen display. DLSS helps a bit the situation with the 1% low frame rate, but introduces CPU limitation. We can see that the value of the GPU utilization is no longer 100%. There is also a big difference in frame time when raytracing is enabled, from 8 milliseconds to 14 milliseconds, that is 75% more. This graph is very interesting. Here we can see that enabling raytracing brings our 1% low frame rate down by 60% and the average frame rate down by 32%. The average frame rate could be understood, but the 1% low frame rate makes the game an unpleasant experience. Enabling DLSS on quality introduces CPU limitation on the RTX 4090, but what is interesting to assess is that it increases the 1% low frame rate by 50%, making the experience with raytracing much better. The average frame rate is only increased by 4% because of the introduced CPU limitation, but it is still an increase. Hopefully the developers will give us a patch soon which will make the game better utilize the hybrid architectures of the Intel CPUs. I am sure this will solve the stuttering issues and the gameplay will be much smoother. If you enjoy the video, please consider leaving us a like and a comment down below. Your feedback is greatly appreciated and will help in producing better videos. Thanks for watching.